Okay, so today we are going to talk about planning clocking domains for Dante, Q-LAN, and AES67. This is a class that we do fairly regularly, and judging by the almost 50 people that are in this class, it is a class that we feel like we almost can't do enough. It is quite literally one of the foundational points of setting up your network and setting up moving audio between devices, whether that's between Dante devices, Q-LAN devices, AES67 devices, or even third-party devices, or I'm sorry, even anything that's going on the network. All of it revolves around clocking. So setting it up properly is really important. So let's talk about our first concept, which is PTP. This stands for Precision Time Protocol. You will see us refer to two different things. One of them is PTP v1, which is the protocol that Dante uses. The other is PTP v2, which is the protocol that Q-LAN and AES67 use. Understand that AES67 is sort of the foundational basis for both Q-LAN and Dante. That's why you'll see newer Dante devices that will let you put them into AES67 mode. That's also why AES67 just works out of the box with Q-SYS devices and doesn't require any kind of special licensing or anything like that. All it does is count towards your total network channels, and you're good to go. So let's talk about setting PTP. This requires a multicast. This requires multicast to be enabled on the network. I get a lot of questions of people saying, "Oh man, I can't send audio between cores." In fact, I had 2 or 3 of them just last week. I can't send audio between cores, and my discovery won't work. My cores can't see each other. Okay, well, I'll bet dollars to donuts that you've got multicast turned off on your switch or on your network somewhere, because all of those things that I just described require multicast on the network. So what happens is a sync packet gets sent out, multicast, it just gets shotgunned out along with the current time. From the master, the slave then responds back to it. And then the master replies back again with the final syncing, and that's how it goes through. So how do we determine which one is the master? Well, that is based on a couple of things. There's an election that happens every time a device is added to the network. A re-election happens. There are ways to manipulate the priority of certain devices and make sure that they are the master or are not the master. If you have 2 that are on the same priority, those will be assigned by MAC address. So things to understand: jitter can wreak havoc on your clocking packets. The other thing to understand, and we're going to dig into this in a minute, is setting up your QoS, which is your quality of service. We want to make sure that our timing packets or our clocking packets get the highest priority of traffic on our switch, above audio, above video, above control, above anything else. We want to make sure that our clocking gets there. PTP v1 versus PTP v2. If you want to have something that can communicate with both, there are devices that can communicate with both, and those are referred to as boundary clocks. But a strictly v1 device cannot communicate with a strictly v2 device, and we will discuss more of that as we get through. Okay, so let's talk about some basic clocking scenarios. Scenario number 1, we have 2 standalone core 110s. Lucky you, you have 2 110s. So we have 2 standalone core 110s. We have no audio peripherals. The only items in here are just the cores and some soft phones. What's going to happen in this scenario is there is no clocking required because there are no peripherals and we're not sending audio from core to core. Therefore, no clocking is generated. Q-SYS cores have a method where if they don't detect anything that needs clocking, they won't generate clocking packets. This started around 7.2-ish, early 7s firmware. And there actually is a way, and I'll show you that later on in the deck, where we can actually force on the clocking inside design properties, just in case there is something that you need to clock with that the core doesn't natively recognize as requiring clocking. Okay, so here's our second scenario. We have 2 110s and 2 IO8 flexes. Again, boy, isn't this just a dream scenario. In this scenario, what's going to happen is we have a thing called BMCA, the rhythm. This is what goes through and decides what's going to be the clock master, the clock leader. In this scenario, both of our cores and both of our IO8 flexes are actually on the same network, and they are sitting together where they can all see each other. So only one of the cores will be the master. And if everything is still set to their defaults, it will be the one with the lowest MAC address. Scenario 3, we have some Q-LAN peripherals with priority. So same equipment, only this time what we're going to do is inside design properties, there's a way where we can assign the PTP priority. And what this is going to do is this is going to change how this piece of equipment functions and is treated within the BMCA. By changing that priority, and the priority 1 comes at 254, the priority 2 comes at 100. But by changing the priority 1, that makes it, the closer you get to 1, the higher its priority is. So the things that it runs through when it's trying to set up the BMCA is it looks at priority 1, and then it goes for class accuracy and variance, which are things that we can't manipulate. And then it looks at priority 2, and then it looks at the MAC address. So lowest priority wins. And if you want to take a core and have it be the priority, have it be your clock leader, change its PTP priority 1 down. And this, think of this like taking your number at the DPS office. Number 100 will get called before number 254. So that's how we make this our clock leader. So in this scenario, what we've done is we've taken core 2, we've changed its priority 1 value, and we've made it 100. Core 1 is still sitting at its default of 254. Therefore, core 2 becomes our clock leader. So there is a version, or there is a way within a network where you can set up multiple clocking domains. In the scenario we're going to look at, we have our 2 core 110s, we have our 2 IO8 flexes, but more importantly, what we have is we want to clock these separately. We want to make sure that each one is a clock leader just for it and its peripherals. So what we're going to do is we're going to go through and we're going to set up a PTP v2 domain. This lets us go in, and this is going to say, okay, all Q-LAN devices in this design are assigned to this domain. And all of the cores have this as as a possibility. So and then again, we're going to cover this a little bit later on when we talk about like boundary clocks and things like that. But in this scenario, by taking one of the cores, changing its PTP-v2 domain to alt1, and then leaving the other at its default of 0, what we're going to end up with is we're going to end up with a core in IO8 flex in 0 clocked back to that one core. The other core in IO8 flex will be in alt1 or domain 1, and it's going to clock within itself. The kicker of this is that if you do this, you cannot use Q-LAN transmit receive system links or AES67 transmit receives between those two cores. Because Q-LAN system links and AES67 are clocked protocols, the two devices between which you are sending traffic must also be able to clock against each other. They must be in the same clocking domain. You could use a WAN stream or something that's not clocked, but you can't use anything clocked. So the other thing to remember is that this applies to Q-LAN. This does not apply to Dante. Dante will stay in domain 0 unless you're using a software and a service known as Dante Domain Manager, which we'll cover briefly towards the end of this. Okay. So in this scenario, what we've done since we've created this PTP-v2 domain 1, we've assigned core 2 into it, as well as flex 2 then inherently becomes part of it because it's part of core 2's design file. So now we have two separated clocking domains, each based on the core being the grandmaster, and the flex just inherently follows it. So let's talk about another scenario. Let's talk about a Dante device, but that is running in AES67 mode. What we've got now is we've got our two 110s, we've got our IO8 flex, or our IO8 flexes per core, and we've got a 6IO BT that is AES67 enabled because it's running on an Ultimo X chip. We are also using one of the legacy DX4Is, which is one of the older Aterotech endpoints. This just runs an Ultimo chip. This will become important here in a second. So on the newer devices, the Ultimo X's, the Brooklyns, the Brooklyn 2s, the new Brooklyn 3s, these will allow you to put the Dante, it's a native Dante device, but it will allow you to put it into AES67 mode. And what this does is this turns on the PTP-v2 clock inside of that Dante device. So devices, when you enable their AES67, they still use V1 for their synchronization and their ability to communicate with other Dante devices, but it now makes it a boundary clock because it can now live in the V1 and the V2 space. So why is that important? Well, that is important because in our scenario here, our cores and our flexes and the AES67 side, if you will, of the 6IO BT are all living in our PTP-v2 domain. But since it also lives, it's a native Dante device, its V1 clock is still working. So it can then clock sync with that DX4I, which is in a V1 domain, because it's a Dante-only device. So in this scenario, in order to make all of this stuff be happy, the 6IO BT has to be the clock leader because it is the only device on this network that can communicate with both pieces of equipment. So let's go through and talk about a way that we can do this a little bit differently. In our new scenario, we're going to have PTP v1, and we're going to set up the priority so that we can better determine what piece of equipment is going to be our clock leader. Same pieces of equipment, 110s, IO8 flexes, 6 IOBT, DX4I. But there's something new that we can do since we have introduced software-based Dante. When we introduced software-based Dante, we gave ourselves the ability to be a boundary clock, because we now have the ability to operate in the AES67 and Q-LAN space for V1, and we are able to operate in the V2 space for Dante. We can do these things. We can now be a clock leader. If any of you are familiar with Dante controller and you go in and you click the checkbox for preferred leader, basically what you're doing is you are changing that pieces of equipment. You're changing its priority one. So in this case, if we want to make sure that our core is our clock leader, deselect everything, make sure nothing is selected as the preferred leader in Dante Manager or in Dante Controller, and then set your PTP priority one to less than 127, or actually, I guess it's 127 or lower, because I believe that all the Dante devices come as a priority of 128. So yes, less than or equal to 127. By doing these two things, once all of this resyncs, the core will become our clock leader. Now, we are still using the 6 IOBT as the boundary clock in this scenario, but our core is the clock leader. So in this scenario, our next scenario, same gear, only this time we're going to run this with software-based Dante. So what we've done is we've enabled our V1 and our V2 clocks on our core by bringing in software-based Dante. The PTP domain only applies to our V2 devices. If we want more Dante domains, we must use DDM. The core can now act as our boundary clock between our V1 and our V2 domain. The kicker on this is you cannot run separate V1 and V2 clocking out of a single core running software Dante. And now this new bullet point underneath this is irrelevant because we no longer have hardware Dante cards in frames or on a 510. But if you have one that is still lying around and you need to do some of these clocking shenanigans, that is the only way to do it. The hardware Dante card existed in a different clocking domain because it was not software-based, it was actually hardware-based. Therefore, you could split the clocking, but in our new software-based Dante scenario, you cannot. So, in this newest scenario, our core is running as the boundary clock, but since we did not change its PTP priority, we left it at 254. It did not win our BMCA. The 6 IOBT did, because as we recalled earlier, those come at 128. So let's go through another scenario again with our Dante, only this time we're going to change the priority one and make sure that our core is now the center of our universe. In this scenario, we have taken the 6 IOBT out of AES67 mode. We have put it back into Dante mode along with the DX4I. The core is our boundary clock and our clock leader, and everything else exists over in our Q-LAN domain over on the side. Jeremy asks, can having multiple V2 clocking domains on a /16-bit subnet or on a /16 subnet cause issues with traffic congestion? Honestly, clocking does not require a lot of bandwidth. So no, that is not inherently a problem. You just really want to make sure that your QoS is strictly applied inside your switch and that your clocking packets are getting the highest priority. Oh, let me click this. Okay, we are 25 minutes into this. We are on the downhill slide of it. I will pause for about 30 seconds in case anybody has any questions before we get into some scenarios. And in fact, I'm going to go grab my water. So give me 2 seconds. And we're back. Okay, so let us go through some real world scenarios. Oh, lost my clicker. There we go. All right, real world scenarios. Here we go. We have a Sennheiser TCC2. This is a Dante device. We have a core. We have 2 peripherals, whether that be an NV or an IO8 Flex or whatever that happens to be. And we have an amp. In this scenario, our ceiling mic would end up being our clock leader because we didn't change anything on the core, and the Dante device gets the priority because it comes at 128. But what if this is a portable system? Yes, a portable system with a ceiling mic. What if this is a portable system that gets connected and disconnected over and over again? This is not a scenario in which we want to have that piece of equipment being our clock leader, because as we've discussed, every time you go through and disconnect or connect a piece of equipment, it goes through and runs the BMCA again. Well, if nothing changes, then nothing happens. The BMCA just runs quietly in the background. However, if a new master is elected, everything has to resync, and you will drop all of your audio for, I don't know, a couple of seconds while everything time aligns and gets happy. So you do not want your clock leader to be in part of something that's going to get connected and disconnected with regularity. So by going through and changing the PTP v1 priority to the core in room B, now we are all nice and happy. And when we connect or disconnect our portable system, we don't have to worry about having a new leader elected every time. So let's do an airport. Here we have 2 redundant 5200s, a truckload of amps, and some paging stations. In this scenario, our clock leader is our core. But should we decide to add in some 6IO-BTs, they would become our clock leaders as well as a boundary clock, because that's what they do. But as we discussed earlier, we will go ahead and implement software-based Dante, and we will also change our priority 1 setting to less than or equal to 127. That's why we always just show it at 100, because we just like to throw it down at 100. Nice, round, easy, fun number. And in this scenario, now our 5200 becomes our clock leader and our boundary clock the way we want it. How about a campus building? Excuse me. We have 3 classrooms, a building PA, an auditorium, and then a little remote input, little axon for our auditorium for our events. But we don't want all of this to clock together. In this scenario, as we first fire everything up, our DBU is actually going to be our clock leader and our boundary clock, because that's a native Dante device. But what I really want is I want to separate all of this because I don't want it clocking together. So what we're going to do is we're going to come through and we are going to set up our PTP-v2 domains so that we can isolate our clocking between 101, 102, 103, the building PA, and the auditorium. The other thing that we can do is we will change our priority 1 settings for the auditorium so that the 510 looking thing in there becomes our clock leader and our boundary clock, because we've got that Axon DBU in there. We are functioning in PTP-v1 and 2. And the other thing that we'll do at this point is, because we've got that PA system, which is inherently sending audio between these different domains and these different cores, at this point, we would use a WAN streamer to do that, because WAN streaming is not clocked. When it comes to building PA, people in classroom 101 will not hear audio out of 102 or 103. People in the auditorium won't hear anything from the classrooms. And if people can't hear 2 things at the same time, it is perfectly fine for them to not be clocked together. No one cares if classroom 101 comes out 5 milliseconds later than the auditorium. No one's going to hear it. Nobody cares. So a WAN streamer is perfectly suited for this application. Whoa. Oh, yeah. So to recap, wow, 35 minutes. So to recap, PTP-v1 is where Dante lives. V2 is where Q-LAN and AES67 live. Clocking is super important, and planning out your clocking domains is super important. You can, and here's the question we got earlier, PTP domains can be used to break up clocking within a subnet. We talked about that a little bit earlier. Our priority can be used to influence clock election. And then software-based Dante allows us to exist in V1 and V2 space to become a boundary clock and to be the leader as part of that. Hey, question, are there issues or added complexity with running a third-party V2 leader clock, having the core run as a follower to the clock and also run the core as a boundary clock for V1? No, not inherently. We see people that do that all the time. When it comes to setting these up, and I will put this out as a general statement for everybody that's watching this webinar. One of the incredible things that I have learned since I came to work here at Q-SYS is we have these very specialized teams of people within our organization. And one of those teams is our networking team. And they are highly skilled. Excuse me. They are highly skilled when it comes to setting up network, setting up priorities, helping diagnose, traffic issues or anything like that. The best thing, if you're trying to set up something really complicated, reach out to your local, area manager or your app engineer, probably your app engineer, and they can set up a meeting with people from our network team, and we can help you go through and lay out exactly what to do. Geez. for those of you who do not live in places of the world like I do, you will be surprised to know that it is still 85 degrees. And I have woken up this morning with a fun case of, mid-November allergies, because things are still blooming and blowing around in the world down here. I had to mow my yard yesterday. That's how crazy things are. And I'm clearly paying the price for it this morning. Let's assume we'll build a network with Dante, AES67, and Q-LAN. Since the QoS values are different for Dante and AES67, what settings do you recommend? We actually cover this in level 2 when we do the whole big long networking thing, which for whatever reason I always end up teaching. The answer is use the Dante QoS settings and then set that up, and then change your core. Hang on, somewhere in here I have a screenshot of this. Well, that's got stuff over it. There we go. Right down here where it says QoS preset, change that to Dante, or to alternate is actually what it says. And then your core will line up with it, and then everything should be all nice and pretty and happy. Oh yeah. Same question every time. I fail to. Whoa, now we all get to see my emails. Same answer every time. I forgot to cover this earlier. There will be in the next week or so a copy of the slide deck, as well as a recording of this webinar that will be emailed out to you. And we always encourage you to sign up for these webinars, even if you know you're going to be late or you can't make it or whatever it is, because by signing up, you are automatically emailed a copy of the webinar or a recording of the webinar along with any presentation materials. So yes, Charles, you will receive a recording, and you can use my dulcet tones to lull yourself to sleep next time you have insomnia. You can listen to me talk about clocking. I should do an ASMR version of one of these webinars where I just give the entire thing in a very slow, smooth tone. No, that would put me to sleep. All right, well, you guys still got me for like another 20 minutes. That's it. Nobody has any other questions other than what is the availability on piece of equipment X? I knew I was talking pretty quickly. I didn't realize I was talking that quickly. I hope I didn't lose anybody. Is multicast always required for clocking? Yes. Clocking starts off multicast. It becomes a directed multicast towards the end. But yes, if there's no multicast, then it won't ever sync up itself. When are the NV21s coming out? That's a great question. I don't know. Side question, software Dante, does the core still have dual NIC redundancy? Yes, but redundancy in the way that we at Q-SYS define redundancy, not Dante primary secondary. Although I guess it could be. I'm not actually sure about that, Peter. Peter, send me an email about that, and I will find somebody who is smarter than me, which is not difficult. I will find somebody that can answer that. For those of you who did join late, or I probably just didn't even I don't even think I gave my little intro spiel. I am the regional application engineer for Texas, Arkansas, Oklahoma, Louisiana, and New Mexico. If you live in one of those 5 states and have technical questions, you are welcome to email me at any time. If not, then you can find your area manager or your regional/local application engineer. But honestly, you're always welcome to email me. Everybody here is everybody at QSE is first name dot last name at QSE.com. So I am steve.mccarry at QSE.com if you need me for something. So yeah, Peter, just send me an email and I will get you an actual legit answer on that. Earlier, you said the election takes place when peripherals are connected. How to prevent the portable system from forcing an election? Okay, so the election itself is not the issue. Elections happen all the time. Those are fine to have happen. It's when a new leader is elected that we have an issue with audio dropping out. So, I mean, just having the BMCA run in the background doesn't cause any issues. You know, when you go hook up your portable system, it's fine. You're not going to hear it. You're not going to notice. Nothing's going to happen. It's only if something in that portable system gets elected to be the clock leader that you will have a dropout issue. So don't sweat that. On a very large project, like a 300-room hotel with ballrooms, conference rooms, common areas, where video, audio, and interface control is required for all zones, would it be best to set up multiple boundary clocks per area, zone, or what? So this is a difficult question for me to just answer in a few minutes. For those of you who know a little bit about my background, this is where I came from, was doing large-scale hospitality, where I did, amusement parks and casinos and hotels and things like that. As much as I hate to see this, that is it depends kind of an answer, which I know is just a crappy answer, but unfortunately, Philip, that is the answer. There's a lot that goes into making that determination. If you want to send me an email, I would be happy to go over some of that with you, offline later on, or set up a meeting with somebody that could really go over that kind of stuff with you. Because that's one where you want to make sure. I mean, and now I will say this, I have done projects of that size with everything being clocked together. I've done casinos where we have an MDF, 7 IDFs, racks of gear in each one. I think we ended up with about 450 total networked devices. Everything had Dante running back and forth, and everything lived in one clocking and Dante domain. And knock on wood, thanks to the fine folks at Extreme Networks, that system is still running today. And it is 10 years old, 10 years old, something like that. All right. Okay. System fault. Blah, blah, blah. Yes, Jeremy, that is probably a clocking issue. If you guys run into specific issues with things, I'll give this as my word of advice for the day. If you guys start running into any of these kinds of issues like this, the best thing you can do is go to the support page, open up a case with support, and give them as much information as you can, screenshots if you've got them, and then those guys will get back with you, and usually that case can then get immediately assigned to one of the specialists for whatever the issue is that you're having, and they can they can help you figure out exactly what you need to solve that problem. There used to be, I'm going to see if it's still here. Under resources, there is a, is it under network solutions? Yes. Okay, David. If you go onto the Q-SYS website, go under resources, you will see a thing under where it says Q-SYS resources that says network solutions. Under that, or on that page, is a whole bunch of information. There is a there's a tab that says like additional documents, I think is what it is, supporting documents, additional supporting documents. If you click there, there is a, here, I'll just show you guys what I'm talking about. So there is, there are switch config examples for audio and video, switch config examples just for audio, and even happier here, switches with known issues. This is not an exhaustive list. Quite honestly, there is a possibility that at some point these manufacturers have fixed whatever the bug was, but at the time this was published, these were switches that we had issues running on. There are also a bunch of white papers about networking resources. So again, I found this under resources, under Q-SYS resources, network solutions, scroll, scroll, scroll. Here are some options about, you know, buying our switches, which are just Netgears, as opposed to manually configuring a network switch. And then if you keep going, here's all networking requirements that you can send to IT people. And then here's our supporting documents. All right. And then here talks a little bit about QoS and IGMP and all that fun stuff. So this is a great resource if you need it. The other thing that I was talking about earlier, if you go to support and go to the self-help portal and scroll down, here it says create a case. If you already have a QSC ID, it will ask you to sign in. If not, you'll need to set one up so we know who you are and what company you're with and all that fun stuff. There are also a ton of like blog posts and things like that when it comes to networking and things like that. All right. So good resources, good places to go if you need anything. All right. Anybody else got any other questions? Once, twice, thrice. Very well. Thank you guys for lending us some time today. As everyone likes to say at the end of these, I'll give you about 12 minutes of your day back. So again, steve.mccarry@qsc.com. If you need me, everyone should receive a copy of this recording. What else? Anything else? I think that's about it. Join us next week. I wish I could tell you what next week is, but I don't remember off the top of my head. Hang on, let me look. Looks like we will be discussing something. Wish I knew. Well, this says clocking, but that's not next week because we did that today. So it will be something. We had to shuffle the schedule a little bit due to some teams. Thank you. I love the fact that you guys know what I'm doing before I know what I'm doing. Thank you. Q-SYS for MTR. Yeah. So thank you. Thank you, Philip and David. Yeah. Oh, great. You can come manage my schedule. All right. So join us next week. Q-SYS for MTR. Have a great week. Let us know if there's ever anything we can do to help you. It's what we're here for. It's what we enjoy doing. So have a great week, and I will see you guys next time. Bye-bye.